Hi everyone. Today we're going to study the parabola with vertex at HK and opens downward. First, let us define parabola. A parabola is a set of all points in a plane equidistant from a fixed point and fixed line in that plane. The fixed point is called the focus of the parabola, and the fixed line is called the directrix. Let us consider this parabola that opens downward and vertex at HK. Let us pick one point of the parabola, denote it as P with coordinates xy, and this represents all the points of the parabola. The standard equation of this parabola is x minus h, and the quantity is squared, equals negative 4a times the quantity y minus k. In this equation of parabola, we need the vertex, and we will substitute these coordinates in here and here respectively. Also, we need the value of this a, and this a is the distance between vertex and focus or directrix. With regard to the vertex and the value a, we can now write the focus. Look at our graph. The focus is here, which is a units below the vertex. The coordinates will be h, k minus a. We have this yellow line here, and this is the directrix. And with regard to our a, this is a units above the vertex. And the equation will be y equals k plus a. Now for the axis, we have this blue line, and this vertical line has the equation x equals h. We define the axis as the line perpendicular to directrix and passing through focus. Next is the latus rectum. Here is the line segment, and we call this the latus rectum. The length is equal to 4a. We can get this value from the positive coefficient of this binomial y minus k. We defined the latus rectum as the chord drawn perpendicular to axis and passing through focus. Now, for the endpoints of latus rectum, here are the two endpoints. The coefficients will be h plus or minus 2a, k minus a, respectively. Let us have this example. The equation of the parabola is x squared minus 6x plus 4y plus 13 equals 0. Sketch the graph. For our solution, we are going to translate this equation into standard equation. First, what we will do is to put all x terms on the left side and all the y term and a constant on the right. We are going to complete the square of the left side by adding this value 1/2b and this quantity is squared. Take note that this b here is the coefficient of x, and that is negative 6. So we will have here x squared minus 6x plus 1/2 of negative 6, and this must be squared. Since this value is added on the left side, we need to add the same value on the right side. So here we go. Simplifying this now, 1/2 of negative 6 is negative 3. And if we square this negative 3, we will get a positive 9. So we will have now x squared minus 6x plus 9 equals negative 4y minus 13 plus 9. On the left side, we are going to factor out, and this will result to the square of x minus 3 equals, the right side will be negative 4y, and we're going to combine this negative 13 plus 9. So the answer is negative 4. Let us factor out the common factor on the right side. See to it that the y variable will be positive. So we're going to factor out that negative 4. So the answer will be negative 4 times the quantity y plus 1. This is now the equation that we are looking for. Let us write again the equation here, and then we can see now that this is a parabola with vertex at 3, negative 1, and opens downward. Remember that this is x minus 3, that's why we write the h to be positive 3, and the y plus 1 means the k is negative 1. So we write here like that. Because of the negative sign on the constant 4, we know that the parabola will open downward. Next, the 4a, that is the positive coefficient of this y plus 1, so we write here 4. We can solve for a now by dividing this equation by the coefficient of a, which is 4. So the value of a equals 1. We can now sketch the graph. Using GeoGebra, the parabola is here, and we graph this equation here. The x squared minus 6x plus 4y plus 13 equals 0. The vertex there is the point 3, negative 1. With regard to our focus, there is now 1 unit below the vertex. So the coordinates will be 3, negative 2. With regard to directrix, that will be the horizontal line 1 unit above the vertex. So this is now our directrix, and the equation is y equals 0. In this example, the directrix conforms with the x-axis. Now the length of latus rectum equals 4. We took the positive value of that coefficient and we write it here. In our graph, this is the latus rectum. We can take the endpoints of the latus rectum using this formula, the h plus or minus 2a, comma, k minus a. So the endpoints are the points 5, negative 2, and 1, negative 2. And the axis is the blue line here. The equation will be x equals h. This h here is the x coordinate of the vertex, which is 3. So we substitute it here. So the axis has the equation x equals 3. This is now our final answer. I hope you learned something from this video. See you again next time.